Within graph theory, you need to know what an incidence matrix is. And today we're going to be looking at going from an incidence matrix to a graph, and also going from a graph to an incidence matrix. So what is an incidence matrix? Well, a matrix, you may or may not have studied it yet, but it's essentially an array of numbers. So it's a grid of numbers. And it tells us how many arcs are connected between any pair of nodes. So this incidence matrix, it have 16 numbers in it, which would represent 4 nodes. And then it would tell us how many arcs are connected between each pair of nodes. So example number 1. Draw a graph described by this incidence matrix. So this incidence matrix has got 5 nodes, A, B, C, D, and E. And we can see that there would have been given the row headers and column headers. And this tells us how many arcs there are connecting between any pair of nodes. So let's just draw our nodes out first. So we've got 5 nodes. So it makes sense to draw them out in a regular pentagon type shape, although you don't have to do that. It just needs to be isomorphic to that. A, B, C, D, and E. Okay, so this says A is connected to B by 1 arc. So there we go, 1 arc. And A is connected to E by 1 arc. There we go. All right, so that is A done. And we probably should check that this is a symmetrical matrix. It is. So if A connects to E by 1, then E connects to A by 1. Okay, example 2, we'll see where that's not necessarily the case and what that means. Okay, node B. Node B connects to A by 1, but we've already got that one in. Node B connects to B by 4, so therefore it's going to have 2 loops. Okay, so this would represent 2 of those 4, and this would represent 2 of those 4. So it's only 2 loops. C connects to B by 2, so therefore I'm going to have 2 arcs between B and C, and B also connects to D by 1 arc, so I'm going to pop an arc in there. Notice you don't have to have straight lines, I just do that on as a nice curved, that's fine. Okay, it doesn't matter, it just needs to be topologically equivalent. C connects to B by 2, we've already done that, so nothing new there. D connects to B, we've done that. D connects to E by 3, so I need to put 3 arcs in here. 1, 2, 3. And there E connects to itself once. And there we go. So this graph is the graphical representation of this incidence matrix. Okay, that is the only answer, but you can have anything that is topologically equivalent to this. Okay, i.e. it needs to be isomorphic. It's not about the shape that it looks like, it's about how the nodes are connected to each other. Okay, that's the important part. Okay, want to do this example as well because this one is not symmetrical. So we can see there is a discrepancy here. So A connects to B by 1 arc, but B does not connect to A. And it does matter which way round. So that's why I want to do this smaller illustration here so we can see what that looks like. So this incidence matrix has 3 rows and 3 columns, therefore it's got 3 nodes in the graph. A connects to itself once with a loop. A connects to B, so A connects to B. We look at the column row header before the column header. A connects to B, so therefore we're going to have an arrow going from A to B because B does not connect to A. We cannot get from node B to node A because that is a 0. So therefore this must be an arrow from A to B because we can get from A to B. All right. The rest of it is symmetrical, so that's the only directed arc on here. A connects to C thrice, so 1, 2, 3. B connects to C once, and that's it. There's no other loops or anything. So that is the graph which is represented by this incidence matrix. Okay, the only other thing I want to touch on is going the other way. So in these 2 examples, we've gone from incidence matrix to graph, but occasionally you might be required to go from graph to incidence matrix. So here I've got a graph, and I want to write down the incidence matrix for this graph. So we've got 6 nodes, so our incidence matrix will have 6 rows and 6 columns. I'm going to put the column headers in, so U, V, W, X, Y, and Z, and then U, V, W, X, Y, and Z. And then matrices have their brackets. and then I'm going to fill this out with how many arcs are connected. So let's just look at U first of all. U does not connect to itself, so the 0 goes in there. U connects to V with 2 different arcs, so we're going to get 2 in there. Nothing is directed on this graph, so it's going to be symmetrical. U connects to W once, and those are the only arcs we have for U, so nothing else. And because it's symmetrical, I can fill in that column. Okay, so this row is going to equal this column. Okay, now we're moving on to V. We don't need to do V with U because we've already done that. V connects to V with a number 2. Don't forget it's got 2 points of contact, even though it's 1 arc. So it's the number 2 that goes in there. V does not connect to W. V connects to X once and doesn't connect to Y or Z. Moving on to W. Oh, hold on, let's do this column. So 0, 1, 0, 0. There we go. Right, W doesn't connect to itself. W connects to X 3 times, so 3 is going to get put in there, and doesn't connect to Y or Z. And then again, fill out the column by symmetry. X does not connect to itself. X connects to Y twice. Just be careful because I've not put those arcs next to each other. One goes round Z and one goes up there. Okay, it's 2 connections, so 2 gets put in there, and it's connected to Z once. Y is not connected to itself, and it is not connected to Z, and Z is not connected to itself. And there we go. There is my incidence matrix for that graph. Thank you for watching. I've got one more video on graphs before we move on to our next topic, and that'll be modelling, so do check that one out. Lots of interesting things in that one. Thank you.